This is problem 8 in chapter 8, where a car that's traveling 10 meters per second collides with a tree and comes to a stop in a very short time, a little bit more than a quarter of a second. Okay, so the question is, what are the average forces acting on a passenger in that car who has a mass of 70 kilograms? First thing to consider is, let's talk about a little more about this equation here. Force equals the change in momentum over the change in time. This was Newton's second law that was originally stated for a more general purpose, where not just the acceleration is present, but where a mass might be changing during an activity. So we've got a situation that's more general. Either a velocity can change, which would create acceleration, or mass can change, or both. So this is a form of Newton's second law, which is broader. Applying this to this equation, or the situation, says the average force that a person feels is equal to their change in momentum. So it's not the car that's stopping. The person is also stopping, and we assume in the same amount of time. So we have a mass of 70 kilograms, that's the person's mass, and they went from a speed of 10 meters per second down to 0, and they did that over a period of time that was 0.26 seconds. So we have an initial momentum of 10 meters per second times 70 kilograms, or 700 kilogram meters per second, and then that comes to a final momentum of 0. And what we get is that that's going to resolve to 2,690 newtons. So is that a big force? Well, that's the force of the seat belts pushing on the person to stop them in that short amount of time. And yeah, that's a pretty big force. That's kind of 2.5 times my weight acting on a person just over the area of their seatbelt. So you don't want to do that too much. Now I've done this very quickly, and we didn't really pay attention to sign, and we really should have. Doing this more properly, we have m delta v over delta t. Well, what we really have is our m is 70 kilograms, that's fine. But we should have said 0 meters per second minus 10 meters per second. Okay, because your final velocity is 0, your initial velocity is 10 meters per second, and then that's over 0.26 seconds. So really our force should be a negative number. And what does that mean? Does that make sense? Well, sure it does. If the momentum is going in the positive direction because the car is going in the positive direction, well, it's very clear that the force has to be applied in the opposite direction, in the negative direction. So by keeping a little more care with our units, it actually provides clarity to the solution.